Let's see. My notes indicate that we made it through problem 19 last time.
Yeah.
And I think it was this 19. Previous problem. Food truck selling salads and drinks.
Yeah, I think so.
Yeah, I looked
We're
back over some of our recorded sessions, and this has to be the 19. There's multiple 19s, unfortunately, but pretty sure this is the 19 that we finished. So if we go on to 20. Now, to be honest, if I look at this, I can't tell whether we are on a difficult section, really, or a medium section, or an easy section, because I don't know where the beginning of the section started.
mhm.
I know SAT goes easy, medium, hard, but I don't know where the section started from. So let's see if we can go backwards just a little bit here. So this section started all the way back here. So in other words, the calculator section is the one I'm looking for. Okay. And what that tells us is that we're well in to the calculator section,
Mhm.
which means we're most likely going to be looking at the difficult or moderately difficult problems, which is fine. We'll have a look at those. What I've found with SAT is that the moderately difficult problems really are just easy problems with 4 steps. You just have to know 4 different things or something like that. Now, let's look at number 20 because there's a lot about number 20 that tells me how to do it. What's the red flag on number 20 that tells me how I should do it?
Uh,
There's something you want to look for. And the something is variables in the problem and those same variables in every answer. Okay? What that tells you is that P can be anything.
yeah.
P is not fixed. So if I want to know how to do this problem, I could use pick numbers as the way to do it. In other words, rather than figuring out what that equals to algebraically, which would be a pain, let's just pick a nice round number for P and figure out what our final price is.
Okay.
Now, P is the amount she paid at the cash register. It included a 20% discount plus an 8% sales tax on the discounted price. So which of the following original prices of the computer in terms of P? So if you had to make up a number for P, what would it be?
It has to be a number that could eat. Wait, it does have to be a number that equals
Yeah,
to
in
the.
other words, when you're going to use the pick numbers strategy, we're not going to come up with an algebraic solution. What we're going
Mhm.
to do is we're going to pick a number for P, and then we're going to work backwards and figure out, well, what was the price of the product?
Okay.
Okay. Now, give me a number for P.
Does it matter what number it is?
Doesn't really. These all have to work. The only
2?
thing that matters is that we pick a P where the math is correct.
Okay.
Okay. So normally if you're picking a P and you have to do percentages of it, try starting with $100.
Okay.
So the computer price, we're going to let it be $100. Now, the store gives her a 20% discount. So what does that drop $100 to?
Percent.
You go in and buy something and it's $100 and they give you 20% off. What are you going to pay?
20% off?
Uh-huh.
I don't know.
Huh?
75? Wait, no.
You go into a store and buy a dress. It's $10. They give you 20% off. What are you going to pay for that dress?
I don't know.
$80.
Oh.
In other words, 20% of 100 is 20. They're giving you a $20 discount. So the price of the dress, or whatever it is you're buying, in this case a computer, it's going to be $80. But then they're going to charge you a 8% sales tax on that discounted price. So what the price you pay is going to be is 1.08, there's the 8% sales tax, times 80. Well, if we do that math,
86.4.
that noise on my end or yours? That must be mine. Hold on one second, Haley. I must have left the TV on accidentally. One minute.
Okay.
All right. Let's see where my little miniature calculator is. Haley?
Yeah.
Okay. So, what we've done is figured out that if the computer, the original cost was $100, then our discounted cost was $80, and we paid an 8% tax on the $80, so this is what we paid.
Okay.
So, what they're asking for is the original price. That's this, C sub P. Okay? So,
Okay.
I know that my final price that I paid was 86.4. So which one of these numbers, that one, that one, that one, or that one, gives you an original price of $100? Because
Would it be?
in my problem, I made the computer original price $100. Okay. Now, this is a little more complicated than it needs to be at this point. I wish it was a little easier, but it's not. But if I can find one of these answers that equals 100, given the price I paid at the checkout was 86.4, that will be my answer. Okay. Well, the first one clearly isn't. That's 0.88 times 86.4. That's not equal to 100. It can't be. How about this one? This one would be 86.4 divided by 0.88.
That's 98.
That's not 100 either. I could tell you that right off the get-go. Well, the next one, let me put that into a calculator. 0.8 times 1.08 times 86.4 equals, that's not 100 either. D has to be my answer. Let's see if that's what I get. 86.4 divided by 0.8 equals, divided by 1.08, bingo, equals $100. So only this one works. In other words, the original price of the computer has to be the price you paid at the checkout divided by 0.8 times 1.08. And it wouldn't have mattered whether I let the computer price equal 100, which I did in our case, or I could have let the computer price equal 500. Wouldn't have mattered. In other words, that's a more reasonable price for a laptop computer, but that is going to give me a certain number, like $450 would be my checkout price. So then I go back through those and realize that that's equal to $450 if the original computer was 500. So it doesn't matter what I let the original price be. I can let it be whatever I want. I can still figure out what the cash register price would be.
Okay.
All right, let's go on just because that one's pretty hard. And in fact, I would say that that one's hard. It's not just pretty hard. If you're trying to figure out how to measure these problems, in other words, the first time through, you want to do all the problems you can do, or all the easy problems. Well, there's a total of 60 problems. This is not one of the easy ones. So you might, when you come to problem number 20, you might say to yourself, okay, I'm going to put a double check mark here. Or I'm going to put an H. Let's use letters instead of check marks. Okay, so if I have easy, medium, and hard, then I put an H there and I go on to the next one. Okay, and when I get my 5-minute warning, when I'm taking the test and the person says you got 5 minutes, I go back, I make sure everything has at least one answer. Never leave a question blank. All right. Let's look at 21. So 20 might be one that you would guess on, because when you're out of time, you want to be guessing on all the hard ones. You don't want to be guessing on easy ones and medium ones. You want to have been able to have done those during the allotted time. But if you have to guess on any, the hard ones are the ones you want to be guessing on. All right.
Okay.
Now, next question is 21. I have not read 21. Is it easy, medium, or hard? Just tell me by looking at it. And don't read it. Just look at it.
Medium. Medium.
I would almost say easy.
Okay.
The reason is there's so many lines of words. That means it can't be hard. There is no super hard problem on this test that has that many sentences in it. Okay? And after all we're doing is looking at a table. So study the table for a few seconds. Look at the title. It's the dreams recalled during 1 week. See that there's 4 columns, actually 3 columns and a total. And then this way, there's 2 rows and a total. Okay? And the thing about these tables, you're going to see these tables on the test. They always have a row total and a column total.
Okay.
So the total amount of people that participated in this sleep survey has to be that number right there. 200. That lower right number. So it's worthwhile getting used to how these tables look. Okay, so we have 2 groups. We have group X, 100 people, and we have group Y, 100 people. If a person is chosen at random from those who recalled at least one dream, well, that eliminates that column, right? Most people didn't recall any. So we're talking about that and that. Those are the people who recalled at least one dream. What is the probability that that person was in that group? Well, probability is all about successes over totals.
Okay.
The total people that recalled more than one dream.
The 5 or more people.
What number is it? Tell me what number is it? We got the total people that recalled more or one or more dreams. One or more dreams.
Wait, what? The total?
If a person is chosen at random and recalled at least one dream, what's the probability they're in group Y? Okay. So tell me how many people in group Y recalled one dream or more.
79.
Okay, that's correct. Tell me how many people recalled more than one dream out of the total, out of everybody, out of the 200. How many people recalled more than one dream? One or more dreams?
100.
Isn't it this plus this?
Oh, yeah, sorry.
What is that number?
164.
What's our answer?
C.
Probability is easy. Probability is the number of successes divided by the number of potential successes. So this really was an easy problem. It was just interpreting the table properly and knowing what probability really was. All right, let's see. I may have to minimize this a little bit. Yeah. Okay. Because both 22 and 23 apply to this table. So, again, before you try to answer 22 or 23, make sure you understand that table. And the way to understand a table, that's the first thing you read right there, the title.
Okay.
Okay? In other words, this is the annual budget for different programs in Kansas for these 4 years. The different programs, there's one, there's one, there's one, there's one, there's one, there's one. Okay? So, we understand the table. Which of the following, let's look at 22. Which of the following best approximates the average rate of change in the annual budget for agriculture, natural resources from 2008 to 2010? So they want the rate of change between that number and that number.
So would I subtract those? Wait, no.
That's a good start.
Okay.
What do you get?
106 minus 308. 129,398. Right?
How many years is that? Going
How
from
many?
2008 to 2010.
2.
Okay. So what's the average rate? If I change by this amount in 2 years, what's my average annual rate of change? Look at the answers. Look at all 4 answers. Notice that there are none that are really close together. This is for 2 years. So take that number, divide it by 2, and pick the answer that's closest to that.
C?
Nope.
I think. Wait, no.
Take that number, use your calculator. Oh, hold on. Is this calculator part or no? I think it is, yeah.
Yeah.
Yeah, this is a calculator part. You can use your calculator.
Wait, so I would divide it by what? Why would I divide it by 2? Why would I not multiply
over
it?
2 years. They want the annual rate. You're coming up with the change you came up with was 129,000 and change. But that's for 2 years. So divide that in half. What do you get? The reason you divide it by 2 is because you're looking for the 1 year change.
I got 64,000.
So what's the answer?
A. Oh wait, no. B.
By a lot. There's nothing closer to 64,500 than 65,000. And it says, which best approximates. They're not looking for the exact number. They're looking for the approximate rate of change. Okay? But the key to this problem is knowing that they're looking from 2008 to 2010. That's going to give you a 2-year rate of change. And they want the average rate of change in the annual budget. So you have to take it down to a 1-year rate of change. All right, let me do that. Now, let's look at question 23. Usually questions about tables can't be that hard. In fact, there's no way this could be hard. This might not be easy, but it at worst is a medium, because all of the information is staring right at you. So all you have to do is interpret the question right.
Okay.
So, which program's ratio of 2007 to 2010 is closest to the human resources ratio, 2007 to 2010? So what's the first thing we have to do?
Find the ratio
Of what?
of human resources.
Okay, so here's the human resources row, and they're going from 7 to 10. So let's find the ratio between that number and that number. Ratio means what?
Subtracting it.
Divide.
9, 2, 1, 3, 7.
Always the smaller number divided by the bigger number.
1.46.
It's the smaller number divided by the bigger number. Can't be greater than 1.
5, 9, 2, 1, 3. 0.68.
Okay, so 0.68. That's the ratio for human services. I'll just list it, and let me list it right here. 0.68. So they want to know which one of these 4 is closest to 0.68. Well, let's just check each one of them. Agriculture, give me that one.
6 divided by 3, 7.
It's the smaller one divided by the bigger one.
3, 7, 3, 9, 0, 4, 8. 0.76.
Next one. Education.
2, 1, 6, 4, 0, 36. 0.71.
Okay, that's closer. Notice we don't have to do general government. That's not one of the answers. We do have to do highways and transportation. Let's have that one.
1, 4, 6, 8, 4, 8, 2 divided by 3, 8, 9, 0.82.
Notice you don't need that much accuracy, right? So you don't really need all these small numbers here. And finally, public safety. Just do 263 divided by 464. Just try that. What do you get?
Oh, I did the whole thing because I got 0.56.
Do you see the advantage of just doing the first few numbers? Don't have to put as many into your calculator. What's the correct answer?
Public safety. No. Yeah, public safety.
No, it's what is closest to that number.
Education.
Okay, that's the answer. And notice that on education, I didn't need those 3 digits there. I could have just divided 2.1 divided by 3.0. and I would have come up with the answer that is closer to 0.68 than anything else. So when you're doing these problems, don't worry about the little numbers. The little numbers don't matter.
Okay.
It's the big numbers that matter. But by that, you know what I mean. In other words, the first few digits, not the last few. All right. Still calculator.
Can I go tell my dog to stop barking real quick?
Sure.
Thank you. Okay, I'm back. Sorry.
It's all right. I wasn't sure if that was your dog or my dog. I actually thought that was on my end. I got barking dogs that kind of surround my house.
Oh, yeah.
Okay. So 24. You need to know the general form of the equation of a circle. Okay?
Mm-hmm.
I used to think you needed to know the general form of the equation of an ellipse also. But I've been working with quite a few SAT people here lately, and I haven't seen any questions on an ellipse. Everything's been on a circle.
Okay.
So if you memorize the equation of a circle, you will no doubt be covered. Now,
Okay.
the equation of a circle, if it's at the origin, is real simple. It's this. Where r is the radius of the circle. Okay?
Okay.
If it's not at the origin, this one is not. This one has a center at 0, 4. Well, then it's x minus the h coordinate of the center plus y minus the y coordinate of the center equals the radius squared. So we don't want to deal with this one. This one, and notice that if h and k were the origin, we would have the original. We would have x squared plus y squared equals r squared.
Okay.
So in this problem, they give us the center. So there's only two answers there that could possibly be right. Which ones are they?
0 and 4.
And this is worth doing, because if you don't know how to do the problem, if you can eliminate some of the answers, you improve your odds immeasurably towards guessing.
Would it be A or B?
That says y minus k. Well, k is 4. So that could be right. That could be right.
Mm-hmm.
Ones that can't be right are that one, because it says y plus 4, and this one, that says y plus 4. Remember, it has to follow this format for the equation of a circle. In other words, if I had something like x minus 2 squared plus y minus 3 squared, Well, then I know my center is at 2, 3, right?
Yeah.
Remember, it's x minus h and y minus k. So the fact that they tell me my center is at z, 4, then it's got to be x minus 0 squared plus y minus 4 squared. Well, the only two answers that fit that format so far are that one and that one.
Mm-hmm.
We can cross off B and we can cross off D. Okay? So now the question is it A or C? Well, this is equal to radius squared. Well, let's see what we're looking at here. But you have to memorize that formula. If you don't have that formula memorized, write it down and put it on the list of things you want to memorize. Okay? If I were to try to draw this circle, well, I know the center is at 0, 4, right there. Okay? And it has an endpoint 4/3, 5. Well, if I go out 4/3, 5, that would be about there. So there's my circle.
Okay.
That is the radius. And remember, what is on the right side of that equation is the radius squared. So if I want to know this radius, I've got to find the distance between these 2 points.
Okay.
Means you need to know the distance formula also. The distance formula is another formula you need to know. Well, the distance formula is the square root of that plus this squared. And now is all I got to do is put in these 2 coordinates and I'll have my answer. Hold on. This is actually going to be easier than it looks because remember, the radius is this thing squared, right? So if I just remove the radical sign, in other words, the distance squared is my radius squared, and that's what's on the right side of the formula. So it's either 5/3 or 25/9. Well, let's figure out what the distance is. The distance between the x coordinates is 4/3 squared plus the distance between the y coordinates is 1. The distance between 5 and 4. So that's 1 squared. And that's actually my radius squared. Excuse me, that's my radius. So my radius squared is that thing without the radical sign. This is what I'm looking for. So that would be 16/9 plus 1. That's going to be my answer. Well, that's 16/9 plus 9/9. That's 25/9. There's my answer right there.
Okay.
Again, hard problem? Not really. Easy problem if you know your equation of a circle and you know your distance formula. But you got to know both of those. If you don't know either one, you're going to have a hard time on this problem. So this might be another one you want to mark with an H and guess on it if you have to, if it comes to that. $25. All of these problems are a little harder. Wow, hold on a second. How far down do they go? Wow. All right. So, in other words, 29 should be the hardest one. Or 30. Okay? So we're definitely in the harder section. And it's important for you to recognize that. In other words, because when you're in the harder section, don't spend a whole lot of time on these problems. Don't spend more than a minute if it's the first time through. If it's the third time through, well then spend whatever you need to on it and then guess if you can't figure it out. But make sure you recognize the difference between the ones you can do and the ones you can't do. Now, 25. This is a typical Algebra 2 problem, but it's definitely Algebra 2. The key word, height. That's what H is. Okay, height, right there. In other words, that's the height of the ball. T seconds after it's launched. Got a person on the ground that's throwing it up in the air. Okay. After approximately how many seconds will the ball hit the ground? What is the height of the ball going to be when it hits the ground? That's what you have to ask yourself. Think about it for just a minute. You're throwing a ball up in the air. What is its height when it comes back down and hits the ground?
What is its height?
Yeah. What's its height when it hits the ground? How far off the ground is it?
25.
Come on, think about it a second. You throw a ball up in the air. It comes back and hits the ground. This is a function that tells you its height at any point in time. So what H is the height above the ground. So what's the height above the ground when it comes back down and hits the ground?
Wouldn't it be that? I'm so confused.
It's 0.
Oh.
You understand why?
Yeah.
Okay. So we're going to set H to 0. That's the entire crux of this problem, is to understand what it means for the ball to come back down and hit the ground. What does that mean about its height? It means its height is 0, right? In other words, at the top of the arc, the height might be 20 meters. Who knows? I don't really care. It doesn't ask about that. It's asking about how long does it take until its height becomes 0. Well, its height becomes 0 when it comes back and touches the ground. So I set H equal to 0, and now I just have to solve that.
Okay.
How do I solve that? It's actually fairly easy to solve.
Don't you have to add the 0?
That's a quadratic, but it's a quadratic that doesn't have a constant. Notice that it has a t squared and a t, but there's no number. So if you go to factor that, that means it's going to be easier to factor because there's no number involved. How would you factor that? Factoring the right side of the equation. Now, the reason you're factoring it is because when you have the sum of two things equal to 0, it doesn't help you. But if you can get the product of two things equal to 0, that is immensely more helpful. Because if I have A times B equals 0, then either A or B has to be 0. So if I can turn this sum into a product, I will be able to solve it. And when I take out a greatest common factor, I do that. I turn it into a product. What's the greatest common factor?
Of both of them?
Of this expression that I've circled, what is the greatest common factor? If I said, take out a greatest common factor, that's the very first step in factoring, is to see if you can find a greatest common factor. It's T.
Oh.
In other words, I've turned in something that was the sum of two things into the product of two things. Now I have T times this thing in parentheses. That's equal to 0. That's a huge concept in algebra. You've got to understand that concept. Is that the reason we factor quadratics is because we have the sum of things equals to 0. Well, nobody can solve that. But if I've got the product, if I've got two things multiplied together that are equal to 0, well, either that thing is equal to 0 or that thing is equal to 0. Well, I don't see that on the answer. That's not one of the four answer choices. So it must be this. So if I set that equal to 0, here's what I get. Minus 4.9t plus 25 equals 0. And now I can solve that for t. I can see clearly that that's the answer. Again, approximately how many seconds? Well, I move the 25 over. Divide both sides by minus 4.9. When I divide 25 by 4.9, I get a little bit more than 5.
Okay.
Okay? So this actually is the easiest problem we've seen today. You didn't have to know any formulas. You didn't have to know anything other than what it means for the ball to hit the ground. What is the consequences of that on height? Because this equation is height. That's what the H stands for. So
Okay.
how many seconds will the ball hit the ground? That means height has to be 0. Plug in a 0 for height, solve it, and I get two answers. One is 0 and the other is a little bit more than 5. All right. And that's a common problem. They're going to give you a vertical, that's projectile motion is what that is, number 25. And you're going to see one of those. So you're always going to see a problem that looks a little bit like that. And they're usually going to, this is fairly hard where they say, when does the ball hit the ground? They could just as easily have said, well, what's the height of the ball at the end of 1 second? In which case you plug in 1 for t and you figure out what h is. But they didn't ask that. That would have been the easy question. They say how many seconds elapse before the ball hits the ground. Well, now you have to plug in 0 for h. First of all, you have to know that that means h is 0. Now, once you plug in 0 for h, you can solve for t, which is what we had to do. All right, let's go back and look at 26. Maybe 27 if we fit it up here. Let's see, what do we have? We have 10 minutes. We started at 4, is that right?
Yeah.
Again, this is going to be a hard section today. I've rarely seen nothing but hard problems, and that's all I've seen today here. So don't get too discouraged by this. In other words, your main goal when you take this test is to make sure you can do all the easy and medium ones. Don't worry if you can't do the hard ones. If you get half the problems right, you get the national average score on the SAT. I don't know if you knew that or not, but that's all you got to do is get half the problems right, and you'll get the national average. I'm reading number 26. Go ahead and read number 26.
The type A trees produce 144 pairs. How many pairs the type B trees produce?
Is this easy, medium, or hard?
Would it be medium?
Not even. Not even. It's easy.
Oh, okay.
Type A produced 20% more than type B. And if type A produced 144,
wouldn't it be 124?
well, let's see. In other words, the one thing I know it's not is D, right?
Mm-hmm.
Because it has to be a number less than 144. Because A produced 20% more than B, and they're asking about B. And they're telling us that A produced 144 pairs. So let's just check our answers. And in fact, we've ruled out D. So let's start with the middle. Let's check and see if 120. Is 120 correct? Well, what's 20% more than 120?
140. Right.
Math. Do it algebraically. Don't just guess. That's a guess. 120% more than 120, or excuse me, 20% more means 1.2. First of all, that means 20% more. And I'm multiplying it by 120. Well, what does that give me?
144.
And that's the right answer.
Mm.
So our first guess was correct. Well, let's say we do this math and it comes up to be 112. What's the answer? Has to be bigger, right?
Yeah.
So it would have to be that without doing any math.
Mm-hmm.
Let's say it comes up to be 150. Then we know it has to be less. That would have to be the answer. So a lot of these problems, when you choose it, notice that we did not solve this algebraically. We did not come up with an equation. The algebraic solution would be 1.2 times x equals 144. Divide both sides by 1.2 and you get x equals 120. That's our answer. But that's the algebraic way to do it. We didn't need to do that. Because all we needed it to do was start with the answers and see if that's the solution. In other words, when I take 144 and multiply, or excuse me, when I take 124 and multiply it by 1.2, I do not get 144. The only number there that when I multiply by 1.2 and I get 144 is B. So that has to be the right answer.
Okay.
27. I guess I'm going to have to scroll down because I think I'm missing, answers. Thought I was looking at the whole problem, but I wasn't. Again, first of all, it's a problem based on a table. So it can't be that hard. Could be hard, but can't be that hard. There's no way it's an H problem. It might be an M, it might be medium. But that's the worst of it. And the only reason it might be an M, if somebody said you have to bet your life, and I've either got to do this problem over here or this problem over here, I would choose 27 in an instant. Because I know that if I spend enough time on 27, I'm going to get it right. Has to be that easy. There's no way it's that hard. And I know that maybe just from experience. I don't know. But let's have a look. So basically there are 10 sections of ground on a 100-meter square plot. And somebody looks and see how many earthworms were in each of the 10 sections. Okay? So in region A, they found 107 earthworms. In region J, they found 166. You with me?
Mm-hmm.
All right. So they went down 5 centimeters into the soil. May be important, may not be. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Now, is this easy, medium, or hard?
Easy, I think.
Yeah, we just got to add up those 10 numbers. Which one are they adding up to? You don't even need to add them up. Don't pull your calculator out. Look at the answers. Look at all 4 answers. And now tell me which answer has to be the sum of those 10 numbers.
D.
B, exactly. Nothing else even close. In other words, every one is approximately 150. 150 times 10 is 1,500. Certainly isn't 15,000. Certainly isn't 150. So this is a super easy problem.
Mm-hmm.
The only hard part about this problem is the 30 seconds it takes to read it, and another 30 seconds it takes to figure out what it is you read. So it's hard, but only in the sense that there's a lot of words to interpret. And then there's this table to interpret. Who would have guessed that the problem would be so easy? Notice this 5 centimeters is irrelevant. We don't need that number.
Yeah.
It's merely saying how many earthworms would you find if you checked the entire field? Well, that's section A, section B, section C, and so forth. Oh. Another really good example of where a problem might look hard, but it's actually really easy. Particularly the way they make their answers. Notice the other thing they did here. They do not make you add up those 10 numbers. You know, had they had an answer of 1450 and another one of 1510 and another one of 1530, well, then you would have had to add up the numbers. but they made it really easy. They made everything be different by a factor of 10. So you don't need to add up any numbers. Just need to know that approximately 10 times the average number there, well, I can see the average number is about 150. So 10 times 150, that's the only thing even close. So this problem is kind of a gift. You just have to understand it. But it is not hard. And it's not hard because of all the words in the table. If anything, that makes it easier. You just have to recognize that. When you see a problem like this, you know it can't be hard. It just can't be. Okay? Just based on my experience of SAT. The hard problems are the short ones. All right, Haley, I will make a note that we got through this 27 worms, I will call it, so I won't have any questions about which number 27 we got through. I will talk to you next time.
Thank you.
You're welcome.